Okay, so 10-3, day 2. Here's our first round of theorems and converses. So theorem, if two chords in a circle or in congruent circles are congruent, then their central angles are congruent. So what they're saying here is if MN, so this guy right here, is congruent to PQ, then these central angles are also congruent. And then the converse is if the two central angles are congruent, then the chords are congruent. So pretty easy stuff so far. The next one, it says if two arcs in a circle or incongruent circles are congruent, then their chords are congruent. So they're talking about this arc right here, MN and PQ. That's telling me that this chord PQ is going to be congruent to the chord MN. Okay? And then vice versa. If two chords in the circle are congruent, then their arcs end up being congruent. Questions on this? Okay. All right, so example 1, proofs with chords. So here's the first thing we got. It says given circle Q, prove SR is congruent to TU. So the easiest thing to do is go SQ is congruent to RQ is congruent to QT and to QU. But we don't want to write it down that way only because of the fact that we have to have things separate for separate triangles, right? So you can state for part 2 that's, let's say, SQ is congruent to TQ, and you would state that maybe RQ is congruent to QU. And that would be by all radii of a circle is congruent. Part 3, we would have that this angle would be congruent with this angle. So I'd state angle SQR is congruent to angle, let's say, TQU. Who remembers why? Good. Very good. Vertical angles theorem. Now that we have this, I can state that triangle SQR is congruent to triangle TQU. And that would be by what? Side angle side. All right, and that makes this congruent with this, which is what we want. So SR is congruent to TU. How? Who remembers? Nikki? Very good. C, P, C, T, C. Questions? How we doing? See, pretty easy. It's not too bad, right? So we just proved one of those theorems. Okay? Now what you're going to do is this. You are going to prove the next theorem. Okay? I'll show you everything, but here's the deal. It says this is the proof for the theorem above. You cannot use the theorem to prove the theorem, okay? So what they're saying is you're proving this theorem is true, so don't use it. Use triangles, okay? So I'm going to give you a few minutes to do that. Yeah. Oh, go ahead. Okay, anybody still working on this proof? Okay. All right, let's check it out. So here's the key for it. Okay, so again, not too shabby. It should have been pretty easy. The thing you needed to be aware of though is that you wouldn't do anything with this middle one. Okay? It's just this triangle and this triangle. Questions? Okay, the next part they want you to kind of try on your own. All right, why don't you give this a shot? We'll go over the answers in a few minutes. All right, show of hands, who's still working on this one? Okay, so let's see if you did this correctly. So looking at this, okay, we have the following. So first off, they're telling us that DE is congruent to FG. So those are the two chords, all right? If those two chords are congruent, that does make the arcs congruent. So arc DE would be congruent to arc FG. EF and ED does not work, okay? In fact, anything involving this triangle CEF is not going to work because we have no information on that triangle. So if you get something like this, kind of darken it out so you don't apply it, okay? Now, because those arcs are congruent, that means the central angles are congruent. So C should have been selected. And these two triangles would have been congruent by side angle side, so E should have been selected. Questions on this one? Anything? Again, triangle CEF, we got nothing on, so we cannot apply it to anything, okay? We only know that two sides are congruent, but we do not know anything about the third side or any of the angles. Questions, comments, concerns? Snyder marks? All right, try these. These in-class practice are for you. So you got 1 through 3, and then the do you know how for 4, all the way to 7. Give these a shot. We'll go over them in a few minutes, okay? Right, show of hands. Who's still working on these? Anybody? If you are, it's fine. I'll just give you more time. Okay, let's check them out. All right, so here's one. All right, so if you look, they're telling you that AGC it's a central angle and it's 90 degrees. Okay, but they're also telling you that AC is congruent to DF, and they're telling you that AB is congruent to EF. So what that's doing is that which angle is congruent to AGB? In this case, again, be FGE. If arc BC is 50, that has to make arc EF 40 because you have to split the 90. And then which segment is congruent to BC? In that case, it's going to be DE, okay, because of that split. Are there any questions on 1 through 3? All right, 4, they're telling you that AC is equal to DF. So that's kind of nice. It says find each measure. Well, they're also, sorry, I forgot the other part. And you also have arc AB is 43 degrees. So since you have that, and you know those two chords are congruent, that means those two arcs would be congruent. So you have arc AB is going to be congruent to arc BC, which is going to be 43 for that one. You know that FD is going to also be 86 degrees because you're adding those up. And then they're talking about arc ABC, so the whole thing again is also 86. And then you have DF is 4, FH is 2, and AC is 4, since you know that those were congruent. Questions on these that I can address? All right. Part 5. So you're given that the radii is 20, and you're given that the chord that intersects, or the center circle and the chord is 15 centimeters. So you needed to find what the whole chord was equal to. After using Pythagorean theorem, you should have gotten 5 or 7 right here. And then you just double it. Who accidentally, and it's okay if you did decimal form for this one? Oh, that's good. That makes me very happy to hear because we are in the exact world now. Okay? Questions on 5. All right, let's take a look at 6. And, 7's right there too. Given AC and AB are tangent segments, solve for X. So this should have been more like a yesterday or a day before thing. Since those are tangent, those are congruent. You set those equal to each other. You set the 10x squared minus 3 equals 11x plus 3. Get everything to one side so it equals 0. And wouldn't you know it, you needed to factor. Your answer should have been negative 2/5 and 3/2. However, 2/5, ew, it's negative. Can you have a negative length? No, you cannot. I think if you substitute into one of them, it became a negative something. I can't remember off the top of my head. But 3/2 does work. Okay? Questions? Yes. You got what? 15? I'll have to look at your work. Well, how about we check that out in a few minutes? All right, 7. In circle P, PE is congruent to PF. AE is equal to X plus 4, and CD is equal to 3X minus 2. Find CD. All right, so again, we know that those distances from the center to the chords are not only creating those perpendicular lines, but also congruent. Now, the key here was this part. They're telling you A to E. They're not telling you A to B. You had to double that. If you didn't double that, you didn't get the correct answer. But they did give you all of CD, which is 3x. So this should have been 3x minus 2. Sorry, I forgot about the minus 2 there. It's there. It's just kind of covered. Equals 2x. 2 times the quantity x plus 4. Okay? You should have gotten CD is 28. Any questions? Comments? Concerns? Snide remarks? No? All right, that's it. Get going on your homework. Those of you watching home, have a great day.